For this problem, let's take a look at this geometric series, summation n equals 1 to infinity, 3 to the n over 2, to determine if it converges or diverges. And if it converges, we will evaluate the sum. There are two ways of going about this problem. Let me do both. And for the exam purposes, you only have to pick one of these. Method number one, square root of n equals 1 to infinity, 3 to the n over 2. Okay, let's kind of write out the terms of this. First would be 3 to the 1/2, then 3 to the first, then 3 to the 3/2, then 3 squared, 3 to the 4/2, 3 to the 5/2, and so on. Okay, now we notice that this is a geometric series. To go from one term to the next, I am multiplying by 3 to the 1/2, by multiplying by square root of 3. And so this is a geometric series. This is a geometric series with the first term is equal to 3 to the 1/2, or square root of 3, and common ratio r is also equal to 3 to the 1/2, which is equal to the square root of 3. And so I have a formula for finding the value of an infinite geometric series if the common ratio is between -1 and 1. However, the common ratio here is something like 1.732. It is bigger than 1. And so since the common ratio is greater than 1, this series diverges. And so that is one answer. The series diverges because it is a geometric series with a common ratio that is greater than 1. All right, method number two. And again, you don't have to show all of these on the exam. I'm just kind of just doing a review purposes of different ways of going about the problem. Negative n equals 1 to infinity of 3 to the n over 2. Now, this is not exactly in the form of a geometric series. A geometric series has the form summation a to the r to the n minus 1. And so let's force this to have the form r to the n minus 1. So I will do this, summation n equals 1 to infinity, 3 to the n minus 1 over 2 plus 1 over 2. If I add these together, I would get n over 2. So this is equal to summation n equals 1 to infinity of 3 to the 1/2 times 3 to the 1/2 to the n minus 1. If I multiply these together, I would get this. And so I get summation n equals 1 to infinity of the square root of 3 times the square root of 3 to the n minus 1. And now this exactly matches the form that I expect. My a is square root of 3, as I saw before, and my common ratio is square root of 3, as I saw before. Okay, and so I have the exact same conclusion I had before. This is a geometric series with first term is equal to square root of 3, and r is equal to square root of 3. And so since the r is greater than 1, this infinite geometric series diverges. Okay, so that's the second method. And as I was recording this, I realized there's actually a third way of doing it. So let me show a third way of doing it. It's method number 3. Notice if I take the limit as n goes to infinity of 3 to the n over 2, that's the limit as n goes to infinity of square root of 3 to the n, 3 to the 1/2 to the n. Here I have a number that is bigger than 1. If I have a positive number that's bigger than 1 to the n, this diverges, that is infinity. In particular, this limit is not 0. So since the limit as n goes to infinity, 3 to the n over 2 does not equal 0, we know that summation n equals 1 to infinity, 3 to the n over 2 diverges by the divergence test. Yep. If the nth term of a series does not go to 0, then we are guaranteed that the series diverges. Okay, so this one did not necessarily rely on any special facts about the geometric series, but used the divergence test instead. All three of these techniques would be appropriate for this problem. Any one of them would have been just fine for the solution for this problem.